Hello everyone, this is the Strange News Observation Room. In 2010, Qantas experienced a famous air disaster, known as the Giant Nemesis of the airborne Titanic. Fully loaded with 469 people, it took off from Singapore, and the plane's engine exploded in midair. Then the system went haywire with error messages. Even the computer indicated that it was doomed. However, the crew managed to turn the tide in this desperate situation. Like a great white shark, Zhang Qing held back the raging waves and carved out a path to survival. In the end, 469 people were rescued, all surviving. This miracle remains one of the most remarkable stories in aviation history to this day. So, what exactly happened back then? And how did the crew showcase their skills to save the plane? Now, let's travel back to 2010 to give everyone a detailed understanding of this perfect aviation incident. Singapore is located in Southeast Asia. Although it is not large in area, its economic development is quite impressive, making it one of Asia's important financial services and shipping centers. About 17.2 kilometers from the city center, there is an airport covering 13 square kilometers, Changi Airport. Since its opening in 1981, the airport has been renowned in the aviation industry for its excellent service. Between 1987 and 2015, it received over 500 awards. Today's story takes place here. On November 4, 2010, a plane carrying 440 passengers was refueling at Singapore's Changi Airport. The passengers were chatting and laughing in their leisure time, unaware that soon they would experience a life-and-death emergency landing that they would never forget. The plane being refueled was the protagonist of our story today, Qantas Flight 32. Its flight route was from London, UK to Sydney, Australia, with a short stopover in Singapore. The entire flight time was approximately 22 hours. It was an ultra-long-haul flight. And the aircraft model was the Airbus A380, which is the largest passenger plane in the world to date, an absolute giant in the sky. It features a double-deck cabin, and when configured for maximum density, can carry up to 893 passengers. This is no joke. It broke the nearly 40-year record held by the Boeing 747 as the world's highest passenger capacity aircraft. This aircraft was put into service in September 2008, just over 2 years after its introduction, and was the first A380 delivered to Qantas. To commemorate Australian aviation pioneers, the plane was named after Australia's first pilot, Sir Charles Kingsford Smith. This aircraft is equipped with 4 engines manufactured by Rolls-Royce, providing ample power. Additionally, it features the most advanced and comprehensive flight systems of the time, making it the most automated aircraft of its era. This provided great convenience for the pilots, allowing just 3 crew members to easily manage it. The captain of this giant aircraft is 53-year-old Richard de Crespigny, who was once a fighter pilot with 35 years of flying experience. The flight time is approximately 15,000 hours. With hours of flight time, he is considered a seasoned veteran. But his time on the A380 is not long, only 570 hours. The co-pilot is Matt Hicks, also experienced, with approximately 11,000 hours of flight time, about 1/300 of which are on the A380. The second co-pilot, Mark Johnson, has approximately 8,100 hours of flight time, of which 1,000 hours are on the A380. Normally, the A380 can operate with just 3 crew members, but today is different. Behind the 3 crew members are 2 senior captains, Harry Woburn and Dave Evans, who have extensive experience. So why are they joining in today? It turns out they are also acting as examiners to conduct the annual assessment of Captain Richard. This means that there are 5 experienced crew members in the cockpit for this flight, which is quite a luxurious lineup. In addition, the plane is equipped with 24 crew members, and with 440 passengers, there are a total of 469 people on board. After 2 hours of refueling and rest, on November 4th at 9:56 a.m., Qantas Flight 32 was fully prepared, and the crew in the cockpit were very relaxed. The captain asked, "Is everyone satisfied with the current condition of the plane?" The co-pilot jokingly replied, "Very satisfied, as long as we don't crash the plane." The plane then took off from Changi Airport, and everything went quite smoothly. Passengers could see the takeoff footage of the plane through the monitors in the cabin. It felt great, and they were chatting and laughing, but the smiles lasted less than 5 minutes. At 10:01 a.m., when the plane climbed to an altitude of 7,000 feet, there were suddenly 2 loud bangs from the plane. Then the plane began to shake violently. At this moment, the passengers did not know what had happened. Although there seemed to be no fire or thick smoke in the cabin, such explosive sounds would make anyone nervous. In fact, many passengers had already started crying and praying. Captain Richard immediately noticed something was wrong and quickly reduced the engine power, switching to manual control to stabilize the plane. At this point, the alarm in the cockpit also went off, indicating that engine number 2 had stopped and caught fire. However, the fire was not a major issue. This is because the engines are equipped with fire extinguishing systems, and the crew can remotely activate these systems to put out the fire. After pressing the deactivation button, the alarm stopped, but engine number 2 was completely out of commission. Don't panic. Let's not panic. As we mentioned earlier, the A380 is equipped with 4 engines, and the most advanced flight systems. Even if one is lost, the remaining 3 engines can still allow the plane to land safely. While the crew was calmly handling the situation, the computer started to go haywire with error alarms, with error codes popping up one after another, more than 5 appearing within a minute. 50 error messages, indicating failures in systems like the fuel system and air conditioning, among others. This situation was a real headache for the crew, as they had never encountered so many faults occurring simultaneously before. To make matters worse, 2 more hidden issues emerged shortly after. Imagine this. If this aircraft, considered the largest passenger plane in the world, were left with only 1 engine, not even a miracle could save it from crashing. Fortunately, although engines 1 and 4 reported errors, they were still operational, albeit in a downgraded mode. The computer system couldn't fully control them, requiring manual operation. Clearly, the previous explosion caused this series of issues affecting the flight systems. Now the computer is frantically reporting errors, and the crew is momentarily unsure how to resolve them. Because they have not been trained for a complete computer system failure, such a situation was never expected to occur. It is now certain that the advanced computer system they usually rely on can no longer fully control the aircraft. This giant is in an uncontrollable state, and the situation is extremely critical. The 5 crew members in the cockpit, with their impressive lineup, are not joking around. With their extensive experience, they remain calm and begin to divide tasks seamlessly. Captain Richard focuses on controlling the aircraft, ensuring it flies smoothly. First Officer Matt reads the error messages from the computer. Another co-pilot, Mark, attempts to fix each error message. Meanwhile, the 2 experienced supervising captains have even greater responsibilities. They must make decisions that the flight system cannot make to a certain extent. On one hand, they reassure the passengers that it's not a big issue, just an engine ingestion, and everything is under control, so there's no need to panic. With us here, your lives are not at risk. On the other hand, they quickly work to fix the problems. However, there are simply too many malfunctions. Even the Qantas Information Engineering Department on the ground, after receiving the data transmitted from Flight 32, was baffled and didn't know where to start. No one had ever encountered such a situation before. The captain began to realize that they could no longer wait. All the malfunctions needed to be resolved. The most urgent task now was to land safely. The co-pilot quickly contacted the Singapore side. In fact, they had already informed the airport at the first sign of trouble with the plane, but at that time, they hadn't decided to return. Now, it was time. Fortunately, the co-pilot contacted the Singapore side immediately. Otherwise, the whole world would have thought that the A380 had already crashed. This is because, during the incident, debris from the plane's engine fell onto Batam Island in Indonesia. It was even picked up by villagers. Since the debris had the Qantas logo on it, the news concluded that a Qantas plane had crashed. This truly shocked Qantas CEO Alan. The company's stock price also plummeted sharply. Back on the plane, the crew decided to fly back to Changi Airport, where they had just taken off. Within a range of over 300 kilometers, Changi Airport is the largest. This is the airport with the highest safety emergency landing coefficient. The airport naturally fully cooperated by clearing a 4-kilometer long runway, and all fire trucks and medical personnel were in place. Preparing on the airport side is relatively simple, but it's not so easy on the plane, because many of the plane's functions have failed. The crew first needs to confirm whether the plane can still land safely. The co-pilot came to the cabin and visually inspected the condition of engine number 2 through the window. There were several large holes in the wing on engine number 2, and fuel was still leaking. Understanding the situation, everyone had a clear idea. It was likely that engine number 2 had exploded, causing the hydraulic system, electrical system, and so on to be damaged, which is why the computer was frantically reporting errors. So, before the official landing, it was very necessary to test which functions of the plane were still working. This is a battle, and knowing both yourself and the enemy is the key to victory. First, they tested whether the plane could still turn, tilting left and then right, and everything was fine. The captain also understood the limits of the plane's left and right tilts, keeping it in mind. Then, they proceeded to assess the issues on the plane. The hydraulic system on the wings was damaged. The wings that assist in takeoff and landing were not functioning. The automatic landing gear retraction system was malfunctioning, all of which were unfavorable for a safe landing. Even more critical was the fact that, as the largest passenger aircraft in the world today, it had just taken off with a full tank of fuel not long ago, making its weight a full 40 tons heavier than the maximum safe landing weight. If they were to attempt a forced landing, say, it would be a matter of life and death. The crew used the flight computer to input the current weight of the aircraft and other data to calculate whether the plane could land safely under these conditions. However, the simulated data sent a chill through everyone's hearts. The computer indicated that an overweight landing would be fatal, but would the crew be intimidated by the computer? Of course not, as the people present were all experts. They continued to adjust various parameters to calculate the possibility of a safe landing. Originally, they could have reduced the aircraft's weight by dumping fuel, but the fuel transfer pump lost control. This operation, which should have been simple, could not be completed. They could only let the plane circle for a while longer, reducing the weight through fuel leakage and normal fuel consumption. After repeatedly trying different data, the most ideal data was finally calculated, and the plane would need to taxi 3,900 meters on the ground, while the longest runway at Changi Airport is 4,000 meters. This means there is very little room for maneuver. Everything must be precise. If a fully fueled plane fails to land successfully and causes a fire, the consequences would be unimaginable, and the 469 people on board would likely face a grim fate. After circling for over an hour, the plane began heading towards Changi Airport. First, the nose of the plane was aligned with the runway, and then the landing gear was lowered using the manual system, 2 minutes later, the landing gear was finally successfully deployed and locked, and the captain focused entirely on controlling the descent speed. It must land gently on the ground. If the impact is severe, the fully fueled A380, there is a high possibility of an explosion. Normally, this landing operation is completed by the flight system, but now it can only be done manually. This really tests the piloting skills. The captain is fully focused on controlling the plane. He needs to perfectly manage the flight speed. If the speed is too slow, it will stall and the plane will crash to the ground. If it's too fast, they will overshoot the runway. The computer-calculated data suggests landing at a speed of 146 knots. However, based on his many years of experience, the captain believes this speed will definitely cause a stall, posing great danger. Ultimately, he decides to land at a speed of 166 knots. Any slower, and it would stall. Any faster, and the runway wouldn't be long enough. Currently, of the 4 engines on the plane, the second one is unreliable, and the first and fourth need manual adjustment, leaving only the third engine fully trustworthy. The captain decides to first set the first and fourth engines to operate at the same power to ensure the plane's balance. Then use the third engine to control the speed. As the plane approaches 1.1 points, the stall warning suddenly goes off at 500 feet above the ground, indicating that the plane is flying too slowly. The captain can only increase the thrust of the third engine, but by this time the plane is already very close to the ground, making precise adjustments impossible. With a loud crash, the plane lands. Although there is no explosion on the ground, the danger is not yet over. Because the plane's speed was too fast, 35 knots faster than the normal landing speed, and since the auto brake was no longer functioning, stopping the plane could only be done manually. The critical issue was that the flaps on the wings could not be deployed. We have previously explained the function of the flaps. They can increase lift during takeoff, and help slow down during descent. Among the 4 engines, only the middle engines, numbers 2 and 3, have thrust reversers. Now with engine number 2 lost, only one engine's reverse thrust remains, which means the braking distance will be longer. The captain was seen putting all his strength into the brakes, while the co-pilot shouted, "Brake quickly, brake, step on the brakes." At this moment, the captain almost wanted to say, "I might as well unbuckle my seatbelt and stand up to step on it." Due to the immense friction from the braking, all 4 tyres on the main landing gear had burst. Fortunately, the plane did indeed start to slow down at 1.1. After a period of intense anxiety, the plane finally came to a stop. At this point, it was only 158 meters from the end of the runway. The cabin was spontaneously filled with applause, cries, laughter, and applause echoing throughout the entire cabin. Although the plane had landed safely, the danger was not completely eliminated, because engine number 1 had lost control and could not be shut down. The plane was still leaking fuel, and the ground was quickly covered with it. The temperature was very high due to the friction between the plane's tires and the ground, meaning a fire could break out at any moment. Evacuating passengers at this time was extremely dangerous. Firefighters began frantically spraying water and fire foam. The passengers endured over an hour of anxious waiting. The captain announced, the crew continuously sprayed water inside, but the engine was designed to withstand heavy rain, so water couldn't shut it down. They had to keep spraying firefighting foam until 3 hours after the plane landed, when engine number 1 finally stopped. Only then did the crew feel safe to leave the cockpit. It was a thrilling rescue operation. It finally ended, and none of the 469 people on board were injured. This emergency landing was nothing short of perfect. Qantas CEO Alan, for safety reasons, immediately grounded all A380 aircraft in the Qantas fleet and began investigating these incidents. The issues must be resolved before flights can resume. In fact, the crew realized early on that engine number 2 was the source of the problem, and upon inspection, they indeed found an issue. There is a component in the engine called the turbine disc, which contains nickel alloy and is quite robust. However, the engine manufacturer discovered that the turbine disc was larger than its normal size. Engineers speculated that the reason for this occurrence was that the turbine disc must have been at an abnormally high temperature and spinning at an extremely high speed at the time. This caused it to deform and fracture. The investigation proceeded based on this line of thought. Sure enough, they discovered that before the explosion, there had already been a fire inside engine number 2. The root cause was a small oil pipe that had ruptured, causing fuel to slowly spray around the engine's turbine disc, and then the high temperature triggered a fire. The fire damaged the drive shaft, causing the turbine disc to lose control. The turbine disc spun faster and faster until it couldn't withstand the stress and exploded. The explosion's debris pierced the wing, with one piece even reaching the bottom of the passenger cabin. Since the wing housed numerous fuel lines, hydraulic systems, and electronic circuits, the debris damaged these lines, leading to multiple malfunctions, and causing the flight system to start issuing numerous error alerts. It turned out that the culprit was the oil pipe known as the common short pipe. Engineers measured the oil pipe and found that its wall thickness was quite uneven. The thinnest part was only 0.348 millimeters, roughly the thickness of 3 sheets of A4 paper. It's no wonder there was a problem. Clearly, this was an issue with the production process. The investigation team concluded that the design and quality of the engine manufacturer, Rolls-Royce, were not up to standard. This led to these accidents, so you have to compensate. Faced with this result, the other party did not argue. Ultimately, they provided Qantas with a compensation of 95 million Australian dollars. Meanwhile, the engine manufacturers conducted inspections on all aircraft equipped with similar engines, replaced the problematic oil pipes, and modified the software system to eliminate similar risks. Thanks to this inspection, it was discovered that 34 engines had the same issue. These engines are distributed on 20 A380s, which is simply incredible. After this incident, Qantas spent 139 million Australian dollars to repair the aircraft and replaced 4 engines. It wasn't until April 28, 2012, that this A380 was put back into operation. In 2011, based on the outstanding performance of all crew members, they were awarded the Polaris Award, known as the highest accolade in the civil aviation industry. Captain Richard was awarded the Order of Australia for his outstanding performance during this incident. He later wrote a book titled QF32, which provides a detailed account of the emergency landing operation. Looking back at this air disaster, it was indeed a nerve-wracking experience. The crew, after losing the advanced flight systems they usually relied on, did not panic, but instead handled the situation very calmly. When the computer indicated that it was impossible for the plane to land safely, the crew did not despair or give up. Instead, they boldly tried new ideas and methods, using their extensive flying experience to find a way out of the predicament. In the end, they methodically brought the plane safely back to the ground, saving everyone's lives. On December 16, 2021, the last A380 was delivered to Emirates, marking the end of this model as it has been discontinued. After all, planes with large passenger capacities have higher demands in various aspects. In the current context of energy saving and emission reduction, the discontinuation of 4-engine, high-capacity aircraft is not so surprising. Alright, that's the story of Qantas Flight 32. Please support with a like, comment, and subscribe. Your small gesture is a great encouragement to me. See you next time.